Hello everyone, hopefully you're doing well. In this video, we're going to continue with chapter 6, rational expressions. If for some reasons you missed some of the videos I already posted about this chapter on how to multiply and divide rational expressions, how to add and subtract more rational expressions, how to simplify complex fraction, how to divide polynomials, like doing long divisions of polynomials or synthetic divisions, and also how to solve equations containing rational expressions. In this particular video, we would focus on rational expressions and problem solving. So that's mostly what we're going to do. Is actually solving some problems. The objectives we pursue in this one is mostly on solving equations containing rational expressions for specified variables. We're going to solve number problems by writing equations containing rational expressions. We're going to solve problems modeled by proportion, solve problems about work, and solve problems about distance, rate, and time. I mean, there are so many things we're planning on doing on this chapter. Hang in there and let's go. Problem solving, it's very important I mean, when you solve problems, it's very important to use equations. That's why we do algebra actually. Algebra helps us to solve problems. First of all, we need to read the problems multiple times in order to understand what they ask you to do. Once you understand what they ask you to do after reading multiple times, you need to identify the facts. That means what is given and also what you need to find out. Then, once you identify those, you need to translate those words into a mathematical model that we would call an equations, and you would solve it. Now, then after that, you solve, of course, and you set the solutions. But now, if we focus on solving an equation for specified variables, we would say the same. First of all, you need to clear the equations of fractions or rational expressions by multiplying each side of the expressions by the least common denominator. We see so many we did before. And you use the distributive property to remove grouping symbols such as parentheses, bracket, etc. You combine like terms on one side of the equations. That's the third step. The fourth step, you use the addition property of equations to rewrite the equations as an equivalent equation with terms containing the specified variables on one side and all of the terms on the other side. Sometimes you solve an equations that contain more than one variables. You need to identify for which one of the variables in the equation they ask you to solve it for. Use the distributive property again and the multiplication property of equality to get the specified variables. I think I said enough on this one. Let's try it on an example. If they ask you to solve the following equation for R1, so remember, the goal for us here is to solve it for R1. So we need to do it for R1 only. Okay. So if we want to do it for R1, where is R1? R1 is right there. Oh my God, that make it so difficult to find R1 where it is. There are multiple ways we can do it. The first way to do it, because we're looking for R1, we can isolate R1 on one side. So what we're going to do, we either looking for the least common multiples. I mean, the least common multiple here would be R1, R2. But how about we subtract 1 over R1 both sides? Subtract 1 over R1 both sides, right? If you subtract uh, you know what? We're gonna keep R1 where it is. Let's subtract 1 over R2 minus 1 over R2. So we end up with 1 over R minus 1 over R2 equals 1 over R1. All right. Now, what if we multiply both sides by R1? So if we multiply both sides by R1, okay? If we multiply both sides, you know what? I'm gonna do I think I chose mm, the longest one. I would go instead with the least common multiples. If we go least common multiple or least common denominator, look at that. We know the first denominator is R, the second denominator is R1, and the third denominator is R2. Okay, so now each of them has a very specific denominator. So when we combine all three together, we get the least common denominator. Next step is to multiply both sides of our equations by R, R1, and R2. That's it. Remember, we call it the least common multiplication. So we're going to have R, R1, and R2. We end up on the left with R, R1, R2 over R equals, remember we need to distribute using the distributive property to get rid of the parentheses. So we multiply the LCD with the first term. That means 1 times R1, R1, R2 over R1 plus 1 over 1 times R, R1, R2 over R2. Now we can simplify the common factors. We said here we have R is gone. So what we have left is R1, R2. We cancel R1 in this one. We have left R, R2. We cancel R2 in this one. What we have left plus R, R1. Our goal is to get rid of our denominator on both sides. Now, we no longer have a denominator, but we only have numerators that we call it polynomials. Now, we need what variables we are interested of. We are interested of solving for R1. In this case, we need to move all terms containing R1 in one side. When I look at on the right, I see R1, and when I look at on the left, I see R1, R2. So we're going to subtract R1 to both sides, R1 to both sides, so we can move all our R1s on one side. Now, R1, R2 minus R1 equal R2. Because both terms on the left have R1 as a common factor, we can factor out the common factors, which is R1. We pull R1 outside. From the first term, we have R2 left. From the second term, we have only R left. And on the right, we still have the same R2. Now, when we solve for R1, it's like if you have 2x equals something. In order to solve only for x, we divide both sides by 2. We're going to do the same here because we only need R1. What we're going to do is divide both sides by R2 minus R. R2 minus R. Now, we can cancel the common factor, and we have only R1 left. On the left and on the right, answer is R times R2 over R2 minus R. Remember, you cannot simplify these because in the denominator you have a subtraction sign. In the numerator you have a product, which is so if we had the same thing as in the denominator, we could simplify. So we would conclude our answer when we solve that particular equations for R1, R1 equal R times R2 over R2 minus R. So that's how you solve for any variables. In some circumstances, they could even ask you what any type of formulas they give you. Sometimes they would ask you to solve for a particular variables from that formula. So that's how you're going to proceed to do that. Now, another examples we could do before we even go with that one. Let me insert another slide. I'm going to show you for examples. Let me move it up here. Let's suppose we give you a formula like, perimeter of a rectangle. Remember, perimeter of a rectangle is 2L plus 2W. I could ask you to solve for W. If I ask you to solve for W, the first thing to do is to subtract 2L from both sides. That means you keep only W on one side by itself because this is the variable you are interested to. So P minus 2L equal 2 times W. Now, because we only need W, we can divide by 2 both sides. Now, you see P, which represent the perimeter, minus 2L over 2 equal W. So answer for us when we solve for W is going to be perimeter minus 2 times the length over 2 as our answer. So this is a second example side just for you to see. It's not all the time you would deal with denominator. Now, our second objective is really to see how we can solve number problems by writing equations containing rational expressions. In these equations, the first thing you need to do here, they said the quotient. Anytime they said quotient means A over B, okay? So you have a number on the top and a number at the bottom, okay? The quotient of a number and 9 times its reciprocal is, remember, the quotient of a number and 9 times its reciprocal. That's a fraction I just showed you, but quotient, if you said, the quotient is usually when you divide A by B, if you obtain C is the quotient, or I can even call it Q. Now, what they ask you to do here is find that number where the quotient of that number and 9 times its reciprocal. Let's suppose 4 is a number. What is the reciprocal of 4? Yes, reciprocal of 4 would be 1 over 4. Okay, that's reciprocal of 4. Now, they said the quotient of a number. Let's n be that number. Let n be that number. Okay, now the quotient of a number and 9 times its reciprocal. Okay, because the first thing we read the problem, if we let n be the number and then 1 and then 1 over n be the reciprocal of that number, be the reciprocal of that number. Remember we said, now in order to translate it, we need, first of all, read the problem multiple times, identify the facts and identify what is asked to find. Now we need to translate what we just said into a mathematical model. The quotient of a number n, okay, and 9 times, okay, we've said that number and 9 times because it's a quotient. Quotient is the division sign, and 9 times its reciprocal, 1 over n, is in mathematics is translated as equal sign. So is 1. Okay. We said this, well, we can rewrite it as n divided by 9 over n equal 1. Because when we have a fraction divided by another fraction, the first thing to do is to keep the first fraction as is and multiply by the reciprocal of the second fraction. Now, after you do that, n times n give you n squared over 9 equal 1. If we multiply both sides by 9, we end up with n squared equal 9. Multiply both sides by 9. So when you do that, on the left, you would have only n squared left because you would simplify by 9. And 1 times 9 is 9 would be on the right. Now, what happens when you have n squared equal 9? All you need to do is take the roots of both sides so you can obtain the answer for n. So in this case, n would be equal plus n minus 3. You have two answers for this. You can either use both answers, okay? And now what you can do is go back and plug it back in the equations you have right there. You have an equations here where you translate the quotient of a number and 9 times its reciprocal is equal to 1. If you plug 3 divided by 9 times, okay, 9 times 1 over 3 would give you 3. 3 divided by 3 is equal to 1, which is true. So either the negative or either the positive, both answers would be the same. So in this case, we would conclude that these two numbers are -3 and 3. So those are some very great examples we can use when we want to solve for a number. We can also solve problems modeled by proportions. Like when we solve problems modeled by proportions, ratio is the quotient of two quantities, right? So you can write ratio either A over B, or you can write it A colon B for express ratio. The ratio of a number A can be written like A colon B or A over B. The unit associated with the ratio are important. The units should match. If the units do not match, it is called a rate and not, not a ratio. All right, so remember, ratio and rate are two different things in mathematics. Proportion is two ratio or rates that are equal to each other. So if I have A over B equals C over D, if I want, I can even cross multiply, having AD equal BC. I can do that like this because we can rewrite the proportion by multiplying the LCD BD, or you just say cross multiply. Okay, we call it cross product. Let's go with an examples very quick on this one. If a 170-pound person weighs approximately 65 pounds on Mars, how much does a 9,000-pound satellite weigh? Okay, so first of all, remember we're doing some type of ratio for these problems. If a 170-pound weighs approximately 60 pounds on Mars, so we need to do person on Earth, okay, with satellites on Earth, and we do pounds of person on Mars with pounds on Mars. Okay, so they said if 170-pound person weighs approximately 65 pounds on Mars, okay, so we have 170-pound person. Now let's put pound first. Pound person. Okay. We said that that 170-pound person that would be on Earth. If we compare Earth to Earth, but we know that would be uh, um, okay, let me do that like this. If we do 65-pound person on Mars, so if 170-pound person weighs approximately 65 pounds on Mars, so we're gonna have 65 pounds on Mars. How much does 9,000 pound satellite? We're gonna put the satellite on Earth as well. And how much that would weigh on Mars? Okay, so X pound satellite on Mars. Okay, now all we need to do here to find the correct answer is we can do cross product. That means we have X multiply with we have X multiply with 170. See, we're gonna have 170X equal 65 times 9,000. So if we have 65 times 9,000, so on the left, we have 170 times X equals 65 times 9,000, because the questions, if a 170-pound person weighs approximately 65 pounds on Mars, how much there's a 9,000-pound satellite weight. So we need to use ratio in order to solve these problems. So we end up with 170 x 65 times 9,000. Using a calculator, it would give you 585,000. Now, because on the left, we have our variable x, and we usually solve for x. In order to solve for x, we need to get rid of any coefficients going with x. So because 170 match with x, we need to divide both sides by 170. And when we divide by 170 both sides, we obtain x equal 3,441 pounds. So those ratio problems, we would see them very often. Remember, our goal here is to do one examples, and you can see how that's worked, because here we just go with if 170-pound person weighs approximately 65 pounds on Mars, so 170-pound person on 65-pound person on Mars, and we compare it to 9,000 pounds on Earth over X pounds on Mars. Okay. Now, and next problems we can eventually do, because we can do many examples, because we need to solve different types of problems. Solve problems about work. An experienced roofer can roof a house in 26 hours. A beginner needs 39 hours to do the same job. How long will it take if the two roofers works together? So usually we need to construct a small table, about the problem. First of all, we know if we do work to complete work, for this type of problems, I like to construct a table. The first thing is to take the experience offer. Okay, experienced offer. So let's say for the experience offer, the times is an hour, right? Let's put the times in hour. So the experience offer need how what the experience offer needs. Okay. They said an experience roofer can roof a house in 26 hours. A beginner needs 39 hours to do the same job. How long would it take if the two woofers work together? You cannot just add them because if one person can do the job in 26 hours based on experience, but one person with no experience can do it in 39 hours, even though it looks like you cannot just go ahead and add, or you cannot divide as well because they don't have the same level of experience, but when they work together it should be different. So the experienced woofer do the job in 26 hours. At this point, a portion of job that experienced woofer can complete, portion of job per hour, it's 1 hour of 26. Can do one job in 26 hours. Now, someone who has no experience, let's call that person beginner woofer. I'm gonna call that person a beginner, right? Beginner woofer. Can do the job in 39 hours. So in this case, one job in 39 hours for the beginner woofer. But when they work together, I'm gonna just say together. When they work together, they said, how long is gonna take? What should I put for time in hour? X, or in this case, I'm gonna call it T because when you don't know or the answer yet, you can use the variables. In mathematics, we go with X, Y, Z, but it's all depends on what we want to do. If we see that T, if we deal with time, it's better we use T. Now, working together portion of job would be one job in T that we don't know yet. So you see this first step I do in solving this problem about work, I read and reread the problem by using the times for each woofer to complete the job alone. I can figure out the corresponding work rates in portion of job done per hour. So that's how I said it's way better that we use a table. Since the rate of the two woofers working together would be equal to the sum of the rates of the two woofers working independently, that means, what we mean by that, if remember the first woofer can do one job in 26 hours, and the second woofer can do the same job in 39 hours. Now we said how long it's gonna take them to do one job working together, right? Now, this is how we're going to write our equations. Then we would solve for it. Okay. What I would advise you to do in this case, for this one, is to find the least common denominator. So now we know the denominator would have t in it. What number can divide 39 and 26? One thing I can realize, 39, if you go with 39, remember 39 is 3 times 13. And 26 is 2 times 13. Okay, 2 times 13 is 26. To find the LCD, the least common denominator, remember you take the factors that repeated the most. So I see the 2, I take it. I see the 3, I take it. I see the 13, I take it. So 2 times 3 is 6. 6 times 13. 6 times 3 is 18. 6 times 1 is 6 plus 1 is 78. So that would be our, I included t with it because one of our denominators is t. That would be our LCD. Once you have that LCD, you multiply both sides by 78t, 78t, just to get rid of all those fractions. Now, 78t over 26 plus 78t over 39 equals 78t over t. On the left, what is 78 divided by 26? 26? Yeah, 78, that's 3. 3t. 78 divided by 39. Yes, that gives you 2t. Now, we can cancel tt. We have 78. 3t plus 2t give us 5t equals 78. When you divide both sides by 5, I repeat, I don't do it. So we have 78 divided by 5. We conclude that t would be 15.6 hours. Now, this is our answer, but we need to state the solutions. Working together, so when we substitute, obviously left side will be equal to right side, but we can state the answer. The woofers would take, I'm going to write it here, the woofers would take 15.6 hours working together to finish the job. Okay, that's something we really need to realize. Like, if the experienced woofer can do the job in 26 hours, if the beginner woofer can do the job in 39 hours, but when they work together, you see they can do the job in 15.6 hours. Now, they still finish very early. Other type of problems we can solve, I'm gonna go with only one of them, but there are so many problems involving distance, rate, and times that we can solve using rational expressions. Distance is something that you would always have to deal with because remember, distance is rate times time. So let's say distance is about speed with time. If you drive from Boston to New York, for example, if the distance, or you can either find the distance or you use the speed limit. Let's suppose you are a decent citizen, okay, and you drive only 65 miles per hour from Boston to New York, and you realize you make it in 5 hours. So if you want to know what distance you drive, you would take the 65 miles per hour times the times you spent, which is 5 hours, then it would give you an idea of how many miles is between Boston and New York. Of course, I don't include any traffic. So that's a certain way to see the application of those formulas in real world or in real life. But let's go with these examples. The speed of lazy river's current is 5 miles per hour. This is the speed, or we can call it rate if you want. A boat travels 20 miles downstream in the same time as traveling 10 miles upstream. Find the speed of the boat in Still River. I know that may look a little bit confusing, but what we can do is read the problems again. The speed of a lazy river's current is 5 miles per hour. You know what? What I'm going to do is is construct a table. I believe the table will help us because the distance formula, distance, D is distance. The distance formula is R times T. So bear in mind the distance formula is R times T. D is distance. R is the rate or the speed limit. T is time in hours. Now, as I said, I would prefer to go with, a table again, distance. If I put a table with distance, I believe we have two of them. We're going to have upwards and downwards. So this is a downstream. Okay, if we do the downstream, I like constructibles. So they said, and what is the rate downstream? Because what they said about downstream, the speed of lazy river's current is 5 miles per hour. A boat travel 20 miles downstream in the same time. Okay, 20 miles downstream. So that would be the distance. Let me put the distance, sorry. Distance here. Downstream, the boat traveled 20 miles, okay, per hour. At what rate, please? The rate, if I put the rate would be a boat travels 20 miles down the stream in the same times as traveling 10 miles upstream, okay? Um, Find the speed of the boat in Still River. But the river by itself, already, the speed of the river without the boat is 5 miles per hour. Now, I don't know the speed of the boat going downstream. Okay, I know the distance, but I don't know the speed. But I know without the boat, the rivers already go 5 miles. So I would conclude that the rate with the boat going downstream would be the rate of the boat plus the 5 miles of the river. 5 miles per hour for the river already exists. Now, what is the distance? Remember, we have distance 20. We have rate R plus 5. And during what time they do it? You know, if distance remember, if distance equal RT, now if you solve for T, because that's what we did in the first minutes we started with this video, we can solve for this for a specified variable. If we solve for T, you know T would be D over R. So we would conclude that the time, is D over R. So meaning 20 over R plus 5. I'm going to write it properly. 5 divided, not 5. Okay. 20 over R plus 5. Now, this is the downstream. How about the upstream? Because we need to do both. Traveling upstream. Upstream would be what? Well, a boat traveling 20 miles downstream in the same times as traveling 10 miles upstream. 10 miles upstream, what is the rate now? Okay, the speed of lazy river's current is 5 miles per hour. Because we don't know the rate of the boat, we said downstream is going to be the rate of the boat plus the 5 miles per hour of the river. Now, if we go counterclockwise, like if you know the opposite directions, instead of going down, now we're going up, okay? So the rate would be -5. So -5 would be for the rate. In this case, times is the distance over rate -5. All right. We one thing they tell us, a boat travels 20 miles downstream in the same time. That means the times is the same. So that means time from the downstream is the same as the time to the upstream. That means the times are equals. I can set these two times equal 20 over r plus 5 equal 10 over r minus 5. Once I do that, because I trust this is the problem state that the time to travel downstream was the same as the time to travel upstreams, we get the equality of these two equations. Now, what we can do, two ways, we can go with cross product. We covered that one already. So we're going to have 20 times r minus 5 equal 10 times r plus 5. When you distribute, you're going to have 20r minus 5 times 20 is 100. 10r, 10 times 5 is 50. Okay, next, what you can do is to add 100 to both sides. So if you add to 100, you have 10, 20r equal 10r. 100 plus 50 give you 150. Now, subtract 10r from both sides. If you subtract 10r from both sides, 20 minus 10 is 10, 150. Now, divide both sides by r. We know the rate of the boat. The rate would be 15 miles per hour. This is r. But that's not what they ask you to do, because they said find the speed of the boat in still water. Our goal is to find the rate, okay? So we know what is R. In this case, going upstream would be 20 and going downstream would be 10, all right? If it's okay with you that way. So we can, the speed of the boat, we can just state the answer. The speed of the boat in still water is 15 miles per hour. Well, I think that's it. That's it. I'm hoping this one will help you to understand again how to solve equations containing rational expressions. In a different video, we're going to come back to review a little bit and work over some examples for variation and problem solving. Hope this video helped you to understand, to better understand this chapter. I'll see you in the next video. Take care.